So the next section we're going to go through is 12.2, which is about frequency distributions and statistical graphs. So when we're working with a large amount of data, a frequency distribution kind of lets us see how the observed values fall into a particular category and the amount of time it's going to occur within that category. So listing every single data point might be unreasonable. You might have a million of them. So we want to break it down into different categories. So let's look at an example of what we could do. A hot dog vendor records the number of hot dogs he sells each day at his cart. So these data points, each one of them gives us a particular amount of hot dogs he sells. So one day he sells 15, another day of the month he sells 15 for both of those. Some days he's got higher amounts, so 3 of the days he has 27 hot dogs. So we could make a couple different frequency distributions, but in this case, we can go ahead and just group it by particular numbers. So a particular frequency distribution could have the number of hot dogs as our observed value, and the number of days is the frequency. So if we look at 15, there are going to be 4 occurrences of 15 hot dogs. For 16, we've got 2 hot dogs, and then for 18, we have 6 different data points. And then you can keep going. You can go through each and every class. So if we do 20 hot dogs, we've got 1, 2, 3, 4, 5. If we go through 21, we've got 3 of them, 4 24s, a single 26, and then 3 27s. And you can put all the data points in between. So I'm missing some in here, like we don't have the number 17, that would be 0, so you don't have to write it. Same thing with 19, 22, and 23, and 25. So since they attribute nothing, we just won't put them on the chart. So our rules for grouping is we need to make sure we're keeping everything exactly the same width. And what we mean by that is I shouldn't have some of my classes be like 6 or 7 options and then another one only be 1. We want to keep them exactly the same size. You don't want any overlap, so I can't belong to both categories. You can only belong to a single one. So each piece of data should belong to a single class. So if we're thinking about grouping by ages, you could group 0 to 9-year-olds, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and then you could keep going depending on more people. So every single person will fall into a single one of these categories. You can't be 9 years old and simultaneously be 10 years old. You're one or the other. So the numbers on the left hand are called our lower class limits because they're the lower bound for that group. On the right hand side, they're the upper class. So every single class is going to have 10 values. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers, and there's no overlap. So every person will fit into a single category. So these numbers on the left-hand side are our lower class limits. They're our lower bounds, while the numbers that end the category are called the upper class limits. The width you just find by subtracting 2 of the lower class limits. You could do the same if you subtracted 2 of the upper class limits, you still get the same quantity. So if we look at this particular example, one lower class limit is 20, the class before it is 10, so the class width is 10. 10 minus 0 is 10. If you did 30 minus 20, 10. 40 minus 30, 10. You're always going to get 10 as the class width, so they're exactly the same size. Okay. So let's look at an example. Following set of data represents family income in thousands of dollars of 15 different families. So we want to construct a frequency distribution with this given first class. So the first point has to be 31.6, and the upper class limit for that group is 37.6. So what we should always do, because we're grouping these by numbers, is you want to put this in order. So I'm going to trust you can do things numerically, put everything in the appropriate order. I'd recommend as you kind of go through it. So 31.8 is my smallest value, so I'll cross that off and put it here. Then I go to the next one. Where's my next lowest quantity? It's 35.5. We'll put it there. So this way you can keep track and make sure you hit all the data points, okay? So we need to figure out what my remaining classes are going to be. But we do have some information. So the first class ends at 37.6. My next class is going to have to start immediately after that at 37.7. So if we want the class width, I've got the start of my second class, the start of my first class. You just take the difference between those two. So 37.7 minus 31.5 gives us a class width of 6.2. So our second class is going to end or start at 37.7, and it's going to end 6.2 later. So you add that quantity to 37.6. So we get 43.8. Because remember, if we go back here, if you take the difference in the upper class limits, it's still going to be the class width. So I ended the previous class at 37.6. So it's going to end the class width after that. So 37.8. So now this will tell us exactly how to set up our brackets for our frequency distribution. So what we're going to do is we're going to create a chart. We're going to have the income, which is in thousands of dollars, and then we're going to see the number of families that fall in that category. So our first class is given to us, 31.5 to 37.6. And if you look at the data points that are going to fall in there, you have 2 of them that will be in this particular group. Now my next class ends at 37 will start at 37.7 because it's the number immediately after this. And I have to add the class width, which is 6.2, to this quantity. So we get 43.8. And then the number of data points that will fall in there is going to be 3. So there are 3 groups that fit in here. Okay? So you can kind of go through and calculate each one. So to find all of our starting class limits, just fill in the whole chart here. We take this number, we add the class width, which is 6.2, to get the 37.7. To find the 43.9, we take the previous class limit and we add that class width. So we get 37.7 plus 6.2. Our new class will start at 43.9. To find the 50.1, you would take this previous lower class limit, add the 6.2. So you would do the same exact thing to find all of these values. You start at 37.6, add the class width, which is 6.2. Add the class width, which is 6.2. Add the class width, add the class width, add the class width. So this gives you exactly those brackets that you want to use. Then you just look at your data, you find the number of families that fall into that particular category. And one way you always want to check your work is add all these quantities up. It better be the number of data points you started with. If not, you've done something wrong. Okay? So with this, because we have different classes to signify different things, we will learn about mean, median, and mode in the near future. But if you have heard that at any point in your life, the mode is the one that kind of appears the most. So the modal class is going to be the one that has the greatest frequency to it. So if we look at the previous example, 43.9 to 50 has the most number of individuals that fall into it, so this would be our modal class. And again, you can absolutely have more than one modal. Maybe you have two that have the same number of values. The midpoint is exactly what it sounds like. You can also call it a class mark. It's going to be what occurs in the middle of the class. So you add the upper and lower class limits divided by 2. So like in this last example, the modal class was again this 43.9 to 50 because it had the most. And if you want the midpoint of the second class, which is the 47 or 37.7 to 43.8, you add the upper and lower class limits, divide by 2, and this is the income that falls exactly halfway in between. So because of this, we can use graphs to kind of help us display the same information. So you're seeing the number of families. So if you've done histograms before, those are kind of the main one. So in total, we're going to learn 3: histograms, frequency polygons, and then we'll learn something that's called a stem and leaf plot. Histograms and frequency polygons are very similar to each other, but the histogram is going to use a bar to display the information, while a frequency polygon is going to connect everything via a line, so it creates a polygon. So let's work with a particular example, and we'll go through constructing another frequency diagram, and then we'll construct a histogram and a frequency polygon. So the best way we can really explain it is by going through and doing it. So what we want to start with is we've got all this information, which luckily is in order for us. We want to construct a frequency distribution with a first class of 20 to 30. So what that tells us is we want to look at the age, and then we want to see the number of people that are going to fall into this particular group. So our first one is given. It's 20 to 31-year-olds, or 20 to 30-year-olds. So that tells me my very next group is going to start at 31. I don't know where it's going to end yet, but I know it begins at 31. The way we can find it is we need to look at our class width. So I'm going to take the lower limit and subtract the previous one, which tells us our class width is going to be 11. So to figure out where this ends, I'm going to take the previous upper class limit and I'm going to add the class width to it. So this should end at 41. So my second group is going to be 31 to 41-year-olds. My next group will start at 42. You add 11 to the previous one to get 52 as the ending. And then finally, I still need one more because I do have this one data point and the 54 that will fall into it. My next group will start at 53, adding 11 to the previous upper class limit. It ends at 63. So now I'm going to count up the number of individuals that fall into each category. So if we want 20 to 30 years olds, that's all of these people. There are 10 of them. For 31 to 41-year-olds, all of these people fall in to this particular category. So we have 14 people in this class. For 42 to 52-year-olds, that would be this group of people. So if you count all that up, there's 9 people. And then our last group is the remaining 2 points. We have 2 people that fall into this age category. So if you go ahead and add all of these up, your total would be 35 people. So we've accounted for everyone. Now if we want to find the midpoint for each of these particular classes, you add up the two numbers, divide by 2. So for the first class, 20 plus 30 over 2 gives you 25. For the second class, 31 plus 41 over 2, your midpoint would be 36. The third one would give you 47. And the fourth one, the midpoint is 58. Okay. So you need to calculate these midpoints to be able to write a histogram, because that will tell you all the information about this particular group. So we create our axes. We still put the age at the bottom. And then on the side is going to be the number of people that attended. And you should give a title. So this is the age of individuals at a symphony. So what you need to do is you need to plot the midpoints on the bottom. So we have 4 classes, 4 midpoints. The first midpoint is 25. The second midpoint is 36, 47, and 58. Because by plotting the midpoints, the reader can then infer the class width is 11. So you can figure out and retrace the steps to construct that frequency distribution. On the side, we need to put the number of individuals that attended, and the highest group we have has 14. So I will go up to 14. So I'll count by 2s. So 12, 10, 8, 6, 4, 2. Okay. And now what we do is for that particular midpoint. So for 25, that talks about the first class, we have 10 individuals that fall there. So you're going to plot at 25, 10. And now we're going to construct our histogram from that. So halfway through will be the end of this class, and you keep the same amount on this side. And this gives us everyone who falls into that first category of 20 to 30-year-olds, with the midpoint being 25. So you can reverse engineer everything. For 36, our output is going to be 14. So I'm going to plot 14. And then we're going to continue this line up, flat over, and then it'll go halfway in between the 36 and 47. So now 31 to 41-year-olds, we have 14 that fall in this category. For the third class, we have 9 people that fall in there. So we plot 9 right there. Draw a straight line over and a straight line down. Okay. So 42 to 52-year-olds, there's 9 people. And then finally for 58, we have 2. So continue our line straight, go an equal amount on both sides, and draw a straight line down. So this is our histogram to tell us how many people fall in the class. A frequency polygon, you're going to plot almost identically. The only difference is you're not going to make these bars. You're going to draw straight lines to connect those points. So I'd connect these two, and then go to the bottom. So the red line would give us what the frequency polygon is. So I've already done that here. again, it's going to be almost identical to the histogram, but instead of drawing a bar, you just straight connect the dots. Okay. The last type of way we can organize our data is called a stem and leaf display. So this tells you exactly what the data values are. So you have 2 digits represented for each of these things. We're going to look at breaking that into 2 components. The first digit is what we call the stem, and then the second digit that follows afterwards are called the leaves. So again, the best way we can do this is by looking at a specific example. So all of the ages in this previous one had 2 digits, the 10 digits and then the 1s digits. The first one is our stem and the second one is the leaf. So what we do is we write those first digits. The very first age was in the 20s, 30s, 40s, 50s. Then you draw a bar to indicate the numbers to the left are the stem. And all the numbers that go here are the ones that start with a 2 and then the 1s digit that follows. So that first data point we have was 20, which is 20. So you read it as 20, I have someone that's 20. 23, I have someone that's 23. And the second one tells me I have 2 people that are 23. So you do this for every single data point. You look at all the people in the 30s, you put that 1s digit after. And so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people that are in their 30s that attended the symphony. Okay? And then you just keep doing this. You look at all the people that were in the 40s, put the 1 digits here. All the people that were in the 50s, put the 1 digits there. So if you look at 3 with the bar 1, that represents 31, and there's 2 people that were 31, so that's why you have 2 different ones. 5, 7 represents people that are 57, and you only have 1 person who was this age range. Okay. So the last type of graph that we can use to talk about statistics is a circle graph, but it's more commonly called a pie chart. We aren't going to worry about creating pie charts, but more so interpreting them. So we have a full circle that's going to represent 100% of your population. So all these different things I'm breaking into will be some portion of the total amount, and it'll be a percentage that adds up to 100. So if we look at a particular example, the cost for students to attend the University of Virginia was $20,986 in 2014. This graph shows the percentage for different categories that are broken down in that tuition, or in that cost. So tuition is 48%. So 48% of the $20,986 goes towards tuition. 6% of this total amount goes to books. 21% goes to board, which is like food, that kind of stuff. Same thing with room. Room and board get grouped together all the time. The room is like your physical staying there. The board is the cost of food. So if you add up all of these percentages together, it accounts for 100% of that cost to attend the university. So with that, we want to figure out how much does it cost for each particular category. So what we're going to do is we're going to break it down. We've got 4 different categories, and they each have their own percent. So tuition's 48, room 25%, board 21%, books 6%. We can turn that percentage into a decimal. Just move the decimal twice to the left. So 48% is 0.48. So if we want to find the cost for each particular one, we're going to take this decimal form of the percentage, times it by the total amount, which is the 20,986, and that's going to give us the cost for each category in this full price. So 48% of 20,986 is $10,000. $10,073.28, and likewise for all the other categories. So if you go ahead and add all of those totals back up, you're going to see it's exactly the tuition cost that we started with. If you're off by like a penny or two, it's probably just from rounding. So just round to the nearest cent and be consistent, and then you'll be able to get the cost for each thing precisely.